This is my intermediate algebra course. Today we're going to learn how to graph quadratic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In my previous courses, we learned how to graph linear equations. Here's some examples. And obviously when you graph a linear equation, it looks like a line. Here's some examples. And notice in these equations you have two variables, an x and a y. Anytime you graph on a two-dimensional system, you need an x value for your point, and you need a y value. And in my geometry course, we graphed circles, but other than the circles, we haven't really graphed curved shapes. But today we're going to graph one of the most important curved shapes in the math curriculum. Now, in my previous classes, in this course and other previous courses, we learned how to solve quadratic equations. Here's an example. But what we're going to do is we're going to replace that 0 with y, and we're going to consider that 0 is only a special case when y is equal to 0. And we're also going to consider the possibility that x can be any value and y can be an infinite number of values also. And notice now we have two variables, an x and a y. So that means that we can graph on a two-dimensional system. And when we do that, we come up with these green shapes here. And when you graph a quadratic expression, you get something that we call a parabola. These shapes are called parabolas. And notice these arrows here. That just means that the graph keeps going up and up forever, or down forever. And now when we graphed lines in my previous courses, we could have put arrows because the lines do go on forever, but I just didn't require you to do that. And I don't really care if you put arrows on these parabolas or not. I just put them on these graphs to let you know that the graphs just keep going. They don't stop. And the most important point on a parabola is called the vertex, because that's the turning point. And I've labeled the coordinates of the vertex here. We have the x value of the vertex, vx, and we have the y value of the vertex, vy. V is obviously for vertex, and these subscripts tell you if it's the x value or the y value. Now, when you draw the equation, or write the equation of a quadratic expression, there are three general ways to write the equation. There's standard form, which we've gone over quite a bit in my previous classes in this course, and also my beginning algebra course. But there's also intercept form, and that should look somewhat familiar to you. When you solve a quadratic equation by factoring, you put it in a form very similar to this. And there's also vertex form. Now, when you complete the square, that has some relation to this vertex form, but we really haven't seen vertex form much. But we're going to go over that as we go along in the class today. Now, something else we need to go over is symmetry. We haven't learned symmetry in my classes yet. Whenever you have symmetry, there's a corresponding line of symmetry. These are all lines of symmetry, these red lines. And the reason that those are lines of symmetry is because this half of this rectangle is the exact same size and shape as this half. So that's a line of symmetry. Now, you can also draw a horizontal line through that same rectangle, and you have symmetry in relation to the top and the bottom. And this is a line of symmetry because this half of the circle is the same size and shape as this half. And this is a line of symmetry because this half of the triangle is the same as this half, but it's a mirror image. So you can think of lines of symmetry as mirrors. Now, these are not lines of symmetry because this half of the rectangle is obviously not the same as this half. And this one's a little hard to see down here. It kind of looks like a line of symmetry, but actually, if you're going to draw the same shape on this side, it would actually look more like a coffin. That wasn't perfect, but that's not a line of symmetry. And the reason that we care about symmetry is because these parabolas, when you graph a quadratic expression and you get these parabolas, they have symmetry, because if you draw a line straight through like so, this half of the parabola is the same as this half. They're just mirror images of each other. And we're going to use that to graph parabolas. Now, I know that you know how to plot ordered pairs. I know you know how to plot points on a graph. But because that's so important for the lesson today, we need to go ahead and review that really quickly. Now we have a point -4, 1, and so we're going to go ahead and graph that. Also, I want you to review learning to graph with a table. We used tables in one of my previous courses. I can't remember which one. So if we're going to plot the point -4, 1, because the x value, the first value is the x value, because it's negative, we go to the left, 1, 2, 3, 4. And then the y value is positive, so we go not down, but we go up. And that point is A. And the next point, 2, 5, we go to the right because it's positive 2, and then up because it's positive 5. And there we go. So that is point B. Now we're going to put those in the table. And again, I know what you're thinking. You're thinking, I already know how to do this. I don't need to review this. But I want you to review entering the coordinates in the table also. So go ahead and try C and D, plot those points, and when you come back, we'll do it together. All right, we're back. So 0, -6, that should be down here. And D, which is 4, 3, that would be 1, 2, 3, 4, 1, 2, 3, so that should be there. So again, I know that you already know how to do this, but it's so important for today that I want you to be absolutely sure that you know how to plot these points and make sure that you put them in that table. So we're going to use that today. Now there's one more thing that we need to review before we start graphing quadratic expressions, and that is evaluating expressions. This is an expression here, and we're going to evaluate it. And what that means is we're going to plug in an x value and see what this whole expression equals when you plug in the x value. And in this case, the x value is going to be -2. So I'm going to go ahead and plug in -2. You can see instead of x, I plugged in -2. And so -2 there, -2 there, -2 there, and -2 there. Wherever there was an x value, we just plugged in -2. So now we're going to have to evaluate the expression, but to do that, we need to remember the order of operations agreement. And to remember the order of operations agreement, we have this acronym called PEMDAS. And PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. So P, parentheses, means you do what's inside the parentheses first. So -2 plus 1 is, or -2 plus 3 is 1. And be aware that you can do multiple steps at once. So you can actually do the multiplication rather than waiting for the next step, because we don't really have enough room anyway. Now we have to do exponents. So -2 to the second power is 4. And we can get rid of those parentheses. All right, so now we're going to have to go up here. We're out of room. And 1 to the second power is just 1. 8 times 4 is 32. And now we just combine. 1 plus 8 is 9. 9 plus 32 is 41. 41 minus 2/7 is 40 and 5/7. And if you want to review mixed numbers, you can go to my arithmetic course. And if you want to review the whole concept of evaluating algebraic expressions, you can go to my pre-algebra course, and there's 2 classes on that. Okay, so now we're ready to graph quadratic expressions, and we're going to start by graphing in standard form. That's this form here. And this is an example where we have standard form. And whenever you graph a quadratic expression, the first thing that you have to do is find the vertex point. Remember, the vertex point is the turning point here. And that's going to give us a reference point for the whole graph. Now, this information here tells us how to find the x value of the vertex. And once we find the x value of the vertex, we're going to plug it back into this equation and then find the corresponding y value. That's how it usually works when you're finding the vertex of a quadratic equation or quadratic expression. So what this tells us is if a quadratic expression is written in standard form, this form here, then the x value of the vertex is negative b over 2a. And so let me explain what that means. First, we have to label the constants, just like we did in the previous class. And that information up there tells us that the x value of the vertex is equal to negative b over 2a. And that's the case in every time you have a standard form quadratic expression, the vertex is always going to be equal to this expression here. So let me explain what that means. What that means, and by the way, this is the first step of these problems here. Step number 1. And what that means is that you take b, which we found is negative 12, and you plug it into that expression there. And it's probably best to use parentheses because we're going to have a double negative. And you take a and you also plug it into that expression. So b came from here and a came from here. Then you just simplify. So Vx is equal to, a double negative becomes a positive, so that's just positive 12. And 2 times 3 is 6. And then finally the x value of the vertex is 2. So we found the x value of the vertex. That's this value here. All right, we found the x value, but we need to find the y value also. Remember, a point has 2 values, an x value and a y value. So now we need to find the y value. And to do that, like I said, we're going to take this original equation and we're going to, I'm going to go ahead and section that off. We're going to take the x value of the vertex, which is 2, and we're going to plug it in to that equation. So the y value of the vertex equals 3 times 2 squared minus 12 times 2 plus 15. So I got that 2 from there. And so now we just simplify. The y value of the vertex is equal to 3 times 4, again using PEMDAS. And 3 times 4 is 12, minus 24 plus 15. And looks like we get 3. So I'm going to label that. I'm just highlighting these so you can see where where these numbers are coming from. So now we're going to write a table. That's why we reviewed plotting points and putting those coordinates in the table. So now we have 2, 3 is the first point. That's the vertex point. So let's go ahead and plot that. We're going to go out 1, 2, and up 3. 1, 2, 3. Now we can go ahead and label that, show those coordinates. And at this point, we're going to go to step 2. Step 2 is we're going to find another point on the graph. So basically, just to give you an idea of what we're going to do, we're going to find 2 more points and then connect the dots, and we're going to get our parabola. So step 2, I'm going to choose some x value, some random x value that I'm going to plug in to this equation up here to find the corresponding y value, and then we're going to plot that second point. Now it's very important to understand that if you try to find an x value that's too far away, for example here, it's going to go out of the graph on most of these graphs. So let's say if the parabola looks like that. If you choose an x value over here, an x value here, then it's going to go off the graph because it's going to contact all the way up here. So you want to choose an x value that's very close to this x value So if that x value is 2, then I'm going to choose 3 for the x value. 3 is going to give us this x value here. So if x equals 3, then y is going to be equal to, and we're going to use that same equation. So I'm going to make another red line that shows that we're using that same equation. Now I'm going to section this off. So y equals 3 times, and my x value that I'm using is 3. So if this is 3 here, then we're plugging that in there. And now I'm just going to do the math, and we get 3 times 9 minus 36 plus 15. And we don't really have enough room, so I'm just going to jump forward. So 27 minus 36 is negative 9. Negative 9 plus 15 is 6. So now we can put that those coordinates in the table. So that's 3 and 6. Now I'm going to go ahead and color that. And so now I'm going to go ahead and plot that point. So 1, 2, 3, and then up 6. 1, 2, 3, 4, 5, 6. All right, so again, our parabola is going to look something like this. But I don't have to plug in another x value to find another point. I can use symmetry. Remember, if we draw a line through the x or through the vertex, then we can assume that there's symmetry. This half is going to be the same as this half, which means that this is going to be a point on the graph right here. So now we just connect the dots. Whoops. So connect the dots and don't go out of the window. And there you go. Now, another way to think about it, and I drew that a little bit too pointed. It should be a rounded bottom part there. You don't want it to look like a V. Now, another way to think about this is, we started with an x value of 2, so you can just go over 1 to get this x value, right? Well, you can go to the left 1, which would give you this distance here. Again, going over 1, you get this point. So if you go over 1 the other direction, you should get a point with the same y value. So this point is going to be 1, 6. Again, notice that these have the same y value because there's symmetry. So that is the graph, and you're done. That's called a parabola. Now this is supposed to be rounded down here. It's not supposed to be a V. That's very important to understand. Don't make V's. These are not V's. Okay, these are rounded graphs. My graph didn't look that great. But notice that these graphs are rounded at the bottom or at the top. They're not V's. So make sure that it's not your tip is not too pointed here. Now you might be wondering, wait a second. How did we know that the x value of the vertex was this expression here? Well, we're going to talk about that in the next class, and we don't have to go over it now. So let's go on to number 2. Actually, I forgot to put that last value in the table, so we also have 1, 6. Okay, so on to number 2. We're first going to label the constants. Now notice that there's no coefficient there, so that means a is just 1. And the first step is going to be to find the vertex as usual. So step 1, and of course to find the vertex we use this principle over here, which tells us the x value of the vertex, and we're just going to plug it back into this equation to find the corresponding y value. So the x value of the vertex, in order to find that, we have to use this formula. And then we just plug in numbers. So b is going to be equal to 8, and a is going to be equal to 1. So if you do the math on that, we get 8 over 2, which is equal to negative 4. And so I got that that b value from here, just to be clear, and I got the a value from there. So now we're going to section that off, and we're now going to find the y value of the vertex. To find the y value, we just plug in that x value into that equation. So we have negative 4 squared plus 8 times negative 4 plus 15. And I got that negative 4 from there. And we just simplify that. So the y value of the vertex is equal to 16 minus 32 plus 15. And we have negative 1. And we can make a table. The table just kind of, again, it just keeps track of all the points we're plotting. So we have negative 4 and negative 1. I can go ahead and plot that point. So 1, 2, 3, 4, 1. Negative 4 and negative 1, that is. And so now we have to find another point. So I'm going to, let's see here. Now for this particular problem, I think we can go 2 x values to the right and 2 x values to the left to find our next point. I'm going to go to the smaller number, so I'm going to go 1, 2, so that gives us x equals negative 2. Again, you have to choose x values that are around this x value. Don't choose an x value over here, because if you do that, the point is not going to end up on the graph, because the parabola looks something like this. So if you choose an x value over here, it's going to be way, way off the graph up in the space. Okay, so if x equals negative 2, what is the corresponding y value? Well, to figure that out, again, you have to use the original equation. And we're going to plug in negative 2. So we have negative 2 squared plus 8 times negative 2 plus 15. And just doing the math, we get 4 minus 16 plus 15. And that would be 3. I'm going to put that new point in the table, negative 2, 3. And we'll plot that. So 1, 2, 1, 2, 3. And now we went over 2 from this line of symmetry. We went over 2. And so from that line of symmetry, we can just go over to the other direction, 2. And we know that that's got to be a point. So let's label these points. That would be negative 2, 3. I want you to label all points, by the way. And here we're going to have to go off the graph because we don't have room. So this point is 4. So if we go 2 to the right, that's going to be negative 5, negative 6 is the x value. And we're going to have the same y value as the other point over here. So we can go ahead and put that one in the graph also, negative 6, 3. And then we just connect the dots. So again, that's how you graph a quadratic expression. It's pretty easy. It's not too bad. Again, the vertex is the most important point. And make sure that this is rounded here. You don't want a V. That's incorrect. Okay, so on to the next problem. I'm going to try one more of these before you try one on your own. Now, here's an important point. You see how this coefficient of x squared is negative? That means that this parabola, unlike the previous two, this parabola is going to go down. All right, so that's useful information. But first, let's label the constants. And as usual, the first step is to find the vertex. But we need to start by finding the x value of the vertex, because that's the easiest way to do it. And we just use that formula, and b in this case is negative 4, and a is negative 2. So the x value of the vertex, that's a double negative, so it becomes positive 4. And 2 times negative 2 is negative 4. And so the x value of the vertex is negative 1. So now, again, a vertex is it's an ordered pair, so we have to find the y value of the vertex. To do that, we plug in the x value to the original equation. And I'm going to section that off. So we're going to take this original equation, and we're going to find the y value of the vertex by plugging in -1 to that equation. So the y value of the vertex is equal to -2 times 1 plus 4. I guess I can show the steps there. You don't really have to show the steps here. I'm just doing this for your benefit. Again, you got to follow the order of operations agreement. -1 squared is +1. And then we get -2 plus 4 plus 1. And that becomes 3. So the y value of the vertex is 3. All right, so let's go ahead and plot that. And we can go ahead and make the table first to keep track of the points that we're graphing. So we have -1 and 3. So we have -1, 1, 2, 3. So that's the point right there. Now I know that this parabola goes down, so it's going to look something like this. So I can label my point above so it doesn't run into the graph. It gets kind of annoying when your graph is running into the point. So now I'm going to find an x value that's a little bit farther away. I'm going to find it two units away. So I'm going to plug in 1 for x. So that's step 2. So if x equals 1, then y, in order to find y, we have to use that equation up there. I'm going to section this off. So y is equal to -2 times 1 squared minus 4 times 1 plus 1. And if we simplify that, we get -2 times 1 minus 4 times 1. Again, you don't have to show all these steps. And so on and so forth. Sorry, I'm going to write that a little bit more legible. And then -2 minus 4 is -6, plus 1 is -5. So now we have another point to put in our table, 1, -5. Let's go ahead and plot that. So 1, and then down 5, 1, 2, 3, 4, 5. And then we can use symmetry. That's 2 units away from the line of symmetry. That's 2 units away to the right, so we can go 2 units to the left to find the other point. So that's going to be right there, and that is -3, -5 with the same y value. And then we just connect the dots. And your graph doesn't have to be perfect. And so we'll put that coordinate in. We have -3, -5. All right, so now it's time for you to try. You can. I'm going to go ahead and keep this problem in the window. Now notice the coefficient here on the x squared term is positive. That means that the parabola is going to be opening upwards like this. So try number 4, and when you come back, we'll do it together. All right, we're back. So let's label constants. And the first step is to find the vertex. But to do that, we first have to find the x value of the vertex, and we have to use that equation in order to do that. So the x value of the vertex is equal to -30 over 2 times 5. So simplifying that, the x value of the vertex is equal to -30 over 10, which is then equal to negative 3. So now, again, if we're going to find the vertex, we have to find two values, the x value of the vertex and the y value of the vertex. So the y value of the vertex is equal to 5 times negative 3 squared plus 30 times negative 3 plus 43. And now we just have to do the math. So negative 3 squared is 9. And again, you don't have to show these steps for order of operations, but I'm just doing this for your benefit. And we get 45 minus 90 plus 43. And we get negative 45 plus 43, which is negative 2. So let's go ahead and plot that. That would be about there. And we know the parabola goes up, so I can label the points, or label it below the vertex. I want you to label all your points. And so now we have to choose an x value around there. I'm going to choose an x value that's pretty close to negative 3. So I'm going to try negative 2. So that's part 2 of this problem, is to find a second point. So if x equals negative 2, we're going to find the corresponding y value, but we can't do that unless we use that original equation. So we're going to plug in x equals negative 2 to the original equation. And you can use this equation up here and just plug in negative 2 where you see the green, so we don't have to keep scrolling up. But again, I'm just plugging it into that original equation up there. So now, using order of operations, we have 5 times 4 plus 30 times negative 2 plus 43. And that's 20 minus 60 plus 43. Add all that together and we get 3. So negative 2, 3 is another point. And let's go ahead and plot that. That'll be about there. And so if you draw the line of symmetry, we went over 1 to the right to get that point, so we'll just go over 1 to the left to get to the next point. And labeling these points, we have negative 2, 3, and this would be, we just go over 1 from 3. That gives us negative 4 for the x value of that other point. And it's the same y value. So we'll put that in the table before I forget. Negative 4, 3. And we connect the dots. And it's kind of hard on this graph because it's so narrow, but try not to make this turning point too pointed. Okay, so if you got that graph, good job. Now you may have chosen to find this x value first. That's okay, as long as you got that basic graph. So let's go on to the next problem. And for this problem, be aware that a is 1 because there's no coefficient there, so it's assumed to be 1. And I'm going to go ahead and write those coefficients for you. So go ahead and try number 5. Remember, the first step is to find the x value of the vertex, and you're going to use that equation there, and then you're going to plug the x value back into the equation. That'll give you the y value of the vertex. So try number 5, and when you come back, we'll do it together. All right, we're back. So I'm going to plug in b, which is negative 8, and a, which is 1. So just simplifying, we get double negative becomes a positive, and 2 times 1 is 2. And so the x value of the vertex is equal to 4. So now that we have the x value of the vertex, all we have to do is plug it into the original equation, and that'll give us the y value of the vertex. So the y value of the vertex is equal to 4 squared minus 8 times 4 plus 11. And doing the math on that, we get 16 minus 32 plus 11. And 16 minus 32 is negative 16, plus 11 is negative 5. So that is the vertex. So let's make a table. And we have 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. That's all the way down here. And I know the parabola goes upward because the coefficient of x squared is positive, so I'm going to go ahead and write the coordinate here so it doesn't run into the graph. So now I'm going to choose an x value that's 2 away from the line of symmetry. So if x is 4, I'm going to try 6 over here. Actually, I'm going to go to the left instead of, I'm going to choose a smaller number. I'm going to choose 2, x equals 2. So that's step 2. Let x equal some other number and then find the corresponding y value. But to find the corresponding y value, of course, we have to bring down that original equation, just like we did with the vertex. So if x is 2, we have 2 squared minus 8 times 2 plus 11. And doing the math on that, and I can use parentheses just to, so it's easier to see what's going on here. And we get negative 1. So now we have another point, 2, negative 1. And I'm going to go ahead and graph that. So that's about here. And using symmetry, the other point would be about there. So 2, negative 1. And this point would be 2 over from that x value, which would be 6, negative 1. And we just connect the dots. And I realize I can't really put that coordinate that close. I'm going to move it down later on. Again, this graph is opening upwards because the coefficient of x squared is positive. And that is 6, negative 1. And putting that in the table. So if you got that graph, good job. Okay, on to number 6. I want you to try one more of these. Now, in this particular problem here, notice that the coefficient of x squared is negative. So that means that the parabola is going to open downwards. So just be aware of that. So go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. So first we're going to label those constants. And by the way, you don't need to label the constants. I'm just doing that so you can relate this to what we did in the previous classes. So now step 1 is to find the vertex, but to do that we have to first find the x value of the vertex. And to do that we use that formula. And we plug in b and a, and we just simplify at that point. A double negative becomes a positive. 2 times negative 3 is negative 6. And we get negative 2. So we found the x value of the vertex. But the vertex has an x and a y value. We now have to find the y value. So to do that, we plug in the x value of the vertex into the original equation. And we just simplify. So negative 2 squared is 4. And again, you don't have to show all this stuff. You can just do it quickly in your head if you can. And simplifying, the y value of the vertex is equal to 0. So now we have the vertex. It's negative 2, 0. So that's the first point that we're going to plot there. And that will be here. And the vertex opens downward, so it's going to look something like that. So I'm going to write this, label this point up here so it doesn't run into the graph. So now I'm going to choose an x value that's 1 away from the line of symmetry. So I'm going to choose -1 for x for the second point. If x equals -1, and we can divide this here, then y is going to be equal to whatever the original equation would look like when -1 is plugged in. So we get -3 -1 squared minus 12 times -1 minus 12. So now we just simplify that. We don't really have a lot of room here, so -1 squared is 1. -12 times -1 is positive 12. And if we do the math on that, we get -3. So now we have another point, -1, -3. And we can go ahead and graph that. That's going to be about here. And we use symmetry, go straight across. And this point's going to be -3, -3. And connect the dots. And we're going to go ahead and put that last point in the table. -3, -3. So there you go. If you got that graph, good job. Okay, so now we're going to go on to something different. But before we go on to the using the second form of a quadratic expression, we're going to review x and y intercepts. Now, you learned this in my beginning algebra course, and you also learned it in my geometry course. When you graph lines, this is a linear equation here. Sometimes there's a lot of different ways to do it, but one way is to find the x and y intercepts. So when you find the x and y intercepts, you're finding where the line crosses the axes. So for example, if you draw a line like this, it crosses here at the y-axis. That's called the y-intercept, that value there. And it crosses here at the x-axis. That's called the x-intercept. Now, it's very important to understand, and I'm going to pretend it goes right through 1, 2, 3. It goes right through 4, and that goes right through 3 there. So notice when the line goes through the x-axis, the coordinate here, the coordinate for y must be 0. So that's -3, 0. And this is just some random line. This is not this line over here. I'm just using a random example. So you can see that it goes through -3, 0, and when it hits the y-axis, the x value is 0 and the y value is 4. The important thing to understand here is that when the line goes through the y-axis, the x coordinate is 0. That's always the case. When the line goes through the x-axis, as you see here, then the y value is always 0. So the question is, how do you find the x and the y intercepts? Well, to find the x-intercept, you let the y value be 0, and to find the y-intercept, you let the x value be 0. So if you don't remember what that, what I mean by that, you'll see as we do this practice problem. So we're going to graph this linear equation using the x and y intercept. So first we're going to find the x-intercept. So to do that, we let y equal 0. So we have 2 times x plus 3 times 0 is equal to 6. Then we just get, I'm not gonna do the steps for that because we don't really have enough room. But when you do that, solve for x, you get x is equal to 3. So now if we make a table here, we don't really have a lot of room to make a table, but I'm going to go up here we let y equal 0, and we found that x is 3. So now, step 2, I'm going to find the y-intercept. That's where the graph crosses the y-axis. And we're going to let x equal 0. And if you do that, and we don't really have enough room here, so I'm going to go ahead and move this up here. So if x equals 0, then we're going to plug in 0 for x in that equation. And solving, we get y is equal to 2. So now we have 0, 2. And if we graph, we have 1, 2, 3, 0, and 0, 1, 2. So that point is 3, 0. And this point is 0, 2. And we just connect the dots. So again, this is all review. We're just reviewing how to find x and y intercepts. And my line's not going to be very straight, but you get the point. Now again, you could put arrows. That'd be fine, but I'm not going to require you to do that, because I didn't require you to do that in the previous courses. Okay, so I want you to try example 2. Now understand that example 2 is in slope-intercept form, so technically you could see that this is the y-intercept. If you remember slope-intercept form, remember y equals mx plus b. This is the y-intercept, but I want you to do it the way that we did it in the previous problem, because I want you to understand that principle. So go ahead and try example number 2. Let x equal 0 to find the y-intercept, and let y equal 0 to find the x-intercept, and then use those intercepts to graph the equation. So try example 2, and when you come back, we'll do it together. All right, we're back. So step 1, I'm going to let x equal 0. And so we get negative 4 times 0 plus 5, and y is equal to 5. So that's the y-intercept. So making a table up here, we have 0, 5, and I forgot to label what we were doing there. So that was finding the x-intercept. So now, step 2, we're going to find the y-intercept. Sorry, it's kind of sloppy there. And to do that, we're going to let y equal 0. And then we're going to plug in 0 for y. And we don't really have a lot of room to show the work here, obviously, but that's just going to be x is equal to 5/4. So then we have 5/4, 0. And we can plot those points. 0, 5 is going to be here. I'll go ahead and label that. And 5/4, 0 is going to be about here, roughly. So that is 5/4, 0. So now we can connect the dots. I don't really care that your line is perfectly straight, but it has to look somewhat like a line. A lot of students will do this. That's not really a line. It has to be somewhat straight. Okay, so again, that was reviewing x and y intercepts. So all that said, we're now going to learn how to graph quadratic expressions that are in intercept form. So this is intercept form here, and we're going to approach this the same way that we did the previous problems. Whenever you're graphing, you need to find the vertex first. And this information here tells us how to find the vertex when a quadratic expression is written in intercept form. So it's you can get a screenshot of this if you want, but it's much easier just to show you how to do this rather than to go over this stuff, because that kind of seems a little complicated. But this just says that if a quadratic expression is written in intercept form, this form here, then the x value of the vertex is that expression there, m plus n over 2. So let's explain what that means. First of all, we're going to do this the easy way, but let's label constants. So a is equal to 3, m is equal to 2, and n is equal to 6. So again, that comes from this equation here. So a is just a constant, and m is 2, n is 6. Now notice that these are opposite signs. This was negative 2, so this value was positive 2, and this is negative 6, so this value is positive 6. So what that tells us is it tells us what the x-intercepts are. So that's step 1, is to find the x-intercepts. So one intercept is 2, 0, and the other intercept is 6, 0. Now the reason this is called intercept form is because we can see the x-intercepts just by looking at it. Not the y-intercepts, the x-intercepts. Yeah, and the x-intercepts, as you can probably tell, they're 2 and 6. So that's the first step of the problem, is finding the x-intercepts. So it's 2, 0, and 6, 0. Those are the x-intercepts. So it's important to understand we're not finding the y-intercept. We don't care about the y-intercept on these particular problems. We're just finding the x-intercepts. We're going to worry about finding the y-intercept maybe in a later class. But remember, when you find the x-intercepts, you let y equal 0. See here, we let y equal 0, and we found the x-intercept. Well, you're going to do the same thing with this equation up here. All right. Now, you actually don't have to do this, but I'm just showing you why those are the x-intercepts. So if you let y equal 0, you can see that 2, for example, is an x-intercept. That's where we got that number there. And the reason that 2 is an x-intercept is because if you plug it in, it makes the equation work. So I'm going to plug in 2 for x, and you're going to see that that makes the equation work, because 2 minus 2 is 0, and 2 minus 6 is negative 4. But anything multiplied by 0 is just 0, so you get 0 equals 0. It worked. Plugging in 2 made the equation work. So that's why, we can see the x-intercepts just by looking at this expression. If we plug in 6, then that'll work also, because it'll make this 0. So again, this is called intercept form because we can see the x-intercepts just by looking at it. So you're probably thinking, well, who cares? I don't understand why. Well, what's the point? Well, if we graph the x-intercepts, so that would be 2, 1, 2, 3, 4, 5, 6. Those are the x-intercepts, right? If we graph those x-intercepts, then we can, first of all, we have 2 points on the graph already, and then we can find the vertex, at least the x value of the vertex, very easily, because remember, parabolas have symmetry. So this graph might look like this, or it might look like this, but either way, because parabolas have symmetry, quadratic expressions have symmetry, there's going to be a line of symmetry right down the middle. And that means that whatever this x value is on right in the middle, sorry, these windows keep coming up. Whatever that x value is, that's the x value of the vertex. So you can see it's going to be 1, 2, 3, 4. Now, we don't really need to do much else to find the x value of the vertex, but I just want you to see how this method here works. So I'm going to go ahead and use that method also. So the first step is to find the x-intercepts, which is very easy because we could just look at the graph and see it immediately, or excuse me, look at the equation up here. But the second step is to find the x value of the vertex, and again, we already found it, but I'm just going to find it with that formula. That's another way to do it. So you plug in m and n are the x-intercepts. So the x value of the vertex is equal to 2 plus 6 over 2, which would be equal to 8 over 2, which is then equal to 4. Let me make some room here. And so then at that point, in order to find the y value of the vertex, we just do the same thing we did before. We just take that x value of the vertex we just found and we plug in to the original equation up there. So the y value of the vertex is equal to 3 times the x value of the vertex minus 2, and let me make some more room, times x minus 6. And again, I'm getting that x value from here. I'm just plugging in that x value to the original equation. And so if we simplify, we get 3 times 2 times negative 2, and that becomes negative 12. So now we can make our table for negative 12, and we can go ahead and plot that point. But again, I want you to be aware that you don't need to use this to find the x value of the vertex. That's just a different method. You can just use symmetry and find the midpoint just by using your eyes. But let's go ahead and plot that point. It's 4, negative 12. So we go out 4, 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12, and this point was 6, 0, and this point was 2, 0. And we just connect the dots. So again, this method, or this form, is useful because we can graph the x-intercepts and use symmetry to find the x value of the vertex. It's right halfway between. So now let's go ahead and write those. We can't forget those intercept points we graphed. And that's it. So we got that 2 from there and that 6 from there. So that's just another form that we can use to graph a quadratic equation. So let's try a couple more of these problems. So, and also be aware that we didn't use this value for really much of anything. That value just tells us if the parabola is opening upwards or downwards. So also it's very important to understand that notice that these are opposite signs. So that was positive 4, so the x-intercept is going to be negative 4. And this is negative 2, so the x-intercept is going to be positive 2. Be aware of that. That's very important. And the first step is to find the x-intercepts, which we've pretty much already done. Negative 4, 0, and 2, 0. Again, that's what these numbers signify. And so I'm going to go right on to step number 2, which is to find the x value of the vertex, and we can use that formula. We don't really need to use the formula. We can just find the midpoint between those two x-intercepts. But just to show you how this formula works, I'm going to go ahead and plug in the values. And we get negative 1. And so if we plot the x-intercepts, we've got 1 there and 1 there, and you can see that the midpoint between those should be negative 1. That's why that formula works. And now we're going to take that x value of the vertex and plug it in to the original equation to find the y value of the vertex. So we get negative 2 times negative 1 plus 4 times negative 1 minus 2. So the y value of the vertex is equal to negative 2 times 3 times negative 3. And if you do the math on that, you get positive 18. So now let's make a table to keep track of the points that we're going to graph. I'll put the table here. and the most important point, the vertex, is negative 1, 18. And we've also got the x-intercepts, negative 4, 0, and 2, 0. So now let's plot the vertex, negative 1, 18. So I'm going to go to the left, negative 1, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we have negative 4, 0, and 2, 0. And we're going to connect the dots. And that wasn't a perfect parabola, but you get the point. And so there we go. That's another example where we're graphing a quadratic expression in intercept form and using the intercepts to find the x value of the vertex. So let's try one more of these before you try one on your own. Now, the coefficient, or the constant there is no constant, so it's just considered to be 1. And m is positive 1, and n is negative 4. Again, it's very important to understand that the signs changed. It was negative 1, so it became positive 1, and it was positive 4, so it became negative 4. Now the first step is to find the x-intercepts, which we pretty much already did. And the next step is to find the x value of the vertex. Now we can go to the graph and just find the midpoint of those two intercepts. Now in this case, I think we're going to have a decimal. So this is going to be somewhat annoying for students, and I know what you're thinking. Why do we have to have decimals? Well, you're just going to encounter those in the curriculum. You can't really avoid them. So the midpoint is actually going to be, looks like, negative 1.5. But just to confirm that, we're going to use that formula to find the x value of the vertex. And now we're going to plug in m is equal to 1, n is equal to negative 4. So the x value of the vertex is equal to negative 3 over 2. And you can write it as a decimal if you want. It doesn't really matter. And now we have the x value of the vertex. So now we have to find the y value of the vertex. And to find that, we're going to, as usual, use the original equation and plug in the x value of the vertex. So we have negative 1.5 minus 1 times negative 1.5 plus 4. And again, I'm getting that negative 1.5 from there. And so the y value of the vertex is equal to negative 2.5 times positive 2.5. And you can use a calculator for that if you need to, but it's just going to be negative 6.25. So now I'm going to make a table to keep track of the points that we're graphing. Most important point is the vertex. And then we have the x-intercepts. Okay, so now we're going to graph the vertex, negative 1.5, and then down 1, 2, 3, 4, 5, 6, and a little bit more. So there we have negative 1.5, negative 6.25, and negative 4, 0, and 1, 0. And so again, try to make your parabola rounded. At the bottom here, it's not supposed to be a V. My parabolas are looking a little bit too much like a V. Okay, so that's it. That's another example where we graphed a quadratic equation in intercept form, and we could see the intercepts just by looking at this form. So we could plot those intercepts, just find the midpoint between them, and we could plug that into the equation to find the y value of the vertex. Okay, so on to the next problem. Notice that for number 10, the coefficient, or the first constant there is negative, so the parabola is going to be going downwards, opening downwards. So try number 10, and I'll go ahead and get you started off. So a is equal to -4, m is the opposite sign, so it's -1, and n is again opposite, so it's +3. And the first step is going to be to find the x-intercepts. So go ahead and try number 10, and when you come back, we'll do it together. Alright, we're back. So finding the x-intercepts is pretty easy. It's just -1, 0, and 3, 0. And we can go ahead and put that in a table. I'm going to leave a space for the vertex. And so if we graph those points, that would be here and here. And obviously the halfway point between those would be here. So we know it's going to be, the x value of the vertex is going to be 1. Let's go ahead and confirm that. So the x value of the vertex is equal to m plus n over 2. Plugging in m and n, we get 2 over 2, which is equal to 1. So as we suspected, the x value of the vertex is 1. Now let's find the y value of the vertex. To do that, we take the x value and plug it into that original equation. And then we have the y value of the vertex is equal to -4 times 2 times -2. And we get +16. So now I'm going to put that point in the table. And let's go ahead and graph those points. So we already have the x-intercepts. We just need the vertex. So we're going out 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we'll label these x-intercepts. And we just connect the dots. Sorry. And there you go. So if you got a graph like that, good job. Be sure to label your points on the graph and put the points in a table. So I'm going to leave that in the window. I want you to go ahead and try number 11. Number 11 is also going to be going down because the coefficient here, or the first constant, is negative. So try number 11, when you come back, we'll do it together. Alright, we're back. So I'm going to label the constants. And step 1 is to find the x-intercepts, which we pretty much already did. So let's go ahead and mark those points. We have -1 and -9. And then the point in between is going to be, looks like here, which is about 5. Let's confirm that by using the formula. So step 2 is to find the x value of the vertex and the y value of the vertex. So we're going to use that formula, and we're going to plug in -1 and -9, and we get -10 over 2, and we get -5. Alright, and so now we're going to find the y value of the vertex, and we have to plug that x value of the vertex we just found in to that original equation. So we have -5 plus 1 times -5 plus 9. And so we simplify, and the y value of the vertex is equal to +16. So let's make a table. So we have -5 and 16, -1 and 0, and -9 and 0. Okay, so we already have the x-intercepts plotted, so let's just do the vertex 1, 2, 3, 4, 5, -5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so that is -5, 16, and this is -1, 0, and this is -9, 0. And we just connect the dots. My graph looks like it's kind of pointed. You want to stay away from that. These graphs are not supposed to be pointed. So it should look, kind of rounded like so. All right, so if you got that graph, good job. Okay, so on to number 12. Now for number 12, notice that the graph is, we kind of zoomed in on it, and the graph should be going upward. It opens upward because we have a positive constant there. So for number 12, the vertex is going to be, it's going to have a fraction part of it. So just be aware of that. I know we don't want to deal with fractions, but sometimes you have to. So go ahead and try number 12, and when you come back, we'll do it together. All right, we're back. Step number 1 is to find the x-intercepts, which we pretty much already did. And step 2 is to find the vertex, and we're going to use this formula. So we get 11 over 2. You can keep it as 11 over 2, or you can change it to 5.5, whichever you prefer. And so now we're going to find the y value of the vertex. So we just plug in the x value of the vertex to that original equation. And we get 2 times 0.5 times -0.5. And you can do that in your calculator if you want to, but if you do the math on that, we end up with -1/2. So we have 5.5 and -0.5 and 5, 0 and 6, 0. Alright, so let's plot these points. 1, 2, 3, 4, 5. And 6 is here. And then our vertex is going to be out 5.5. So 1, 2, 3, 4, 5. And then 0.5, that's halfway. And then we go down 1/2. So our point is going to be right there. And that is 5.5, negative 0.5, however you want to write it. And we have 5, 0, and 6, 0. So now we can just connect the dots. Let's not go too high there. We want to stay in our window. And there you go. So if you got that graph, good job. Okay, so now we're going on to graphing quadratic expressions in vertex form. We did standard form. We did intercept form, meaning x-intercepts. You can see the x-intercepts. And now we're going to vertex form, and this is going to be the easiest form to actually graph. And the reason for that is we can just see the vertex by looking at this form. Notice we have a completed square here, and we're now going to use h and k for the vertex. And what this says is if a quadratic expression is written in the form, vertex form, then hk is the vertex. So we don't have to do any calculations. We can just see the vertex. So I'm going to label constants here. So a is equal to 2, and h is equal to 3, and k is equal to 4. Now there's something very important to understand here. Notice that this was a negative 3, and I changed it to positive 3. This was a positive 4, but I did not change it. I kept it positive 4. So that's how this works. Whatever the sign this is, you're going to change it, and that's the x value of the vertex, and whatever sign this is, you're going to keep it and just leave the sign. So I know what you're thinking. You're thinking, I don't know if I can remember that. Well, you can remember it. It's just you just need to put in some effort. With the other problems, with the intercept form, in order to find the x-intercepts, you had to change both signs. These are both negative 5, negative 6. They were both negative, so you had to change them to positive. But that's not the case here. You only change one of them. You change this sign, but you keep this sign. I know that's a lot to remember, but you just gotta remember that. Sometimes there's a lot of stuff in math you have to remember. So the first step is going to be to find the vertex, and I just want you to understand we're now changing the notation. Usually we called it Vx for the vertex. H is the x value of the vertex. Okay, and the reason I'm using this notation is it's just the most common notation. You're going to see it so often that I want to use a notation that's traditionally used. So Vx is h, and that is 3. All right. So just be aware of that. And Vy is equal to k, which is equal to 4. So you don't have to write this. I'm just writing this to let you know that the notation is changing a little bit. Just because we want to get used to what notation is traditionally used. And so the vertex, we don't really have to do any calculations. We know the vertex is 3, 4. So that's why this is the easiest form to use to graph. So let's go ahead and plot that. And that's there. And we know that it opens upward. The reason we know it opens upward is because this constant here is positive. And so now what we need to do is pretty much the same thing we did when you use standard form. We need to choose a point that's pretty close. So I'm going to choose x equals 2, and we're going to find another point. So if x equals 2, then y, we're going to plug in that x value to the original equation, I'm plugging in 2 there. And I just want to be clear where these numbers came from. Actually, I think I'm going to use the same color I used before for the vertex. And I'll use blue for this one, just to show what's going on here. And so we have y is equal to 2 times -1 squared plus 4, just following order of operations. -1 squared is 1. And we get 6. 2 times 1 is 2, plus 4 is 6. I guess I'll just show that just to be absolutely sure that you know what's going on. You don't have to show every step of this. It's not really necessary. And that I'm going to color yellow. So now we can make a table here. So we have the points 3, 4, and 2, 6. So I'm going to plot 2, 6. And then we can use symmetry, of course, to find that other point. And that other point would be 4, 6. And I'm going to connect the dots, and we're done. So as you can see, using vertex form is the best way to graph quadratic expressions. And so let's put that other point in the table. We got 4, 6. Okay, so on to number 14. We're going to do a couple more of these problems before you try one on your own. Now notice the coefficient here is negative, so that means that the parabola is going to be opening downward. So I'm going to start by just labeling constants. A is going to be -1. And by the way, if you didn't get a screenshot, you can go ahead and take a screenshot of this to refer to that. And so A is -1, and H is the opposite sign. It's -1. And K is the same sign. So we don't change this sign, but we do change this sign. Again, I know that's confusing, but that's just something you're going to have to remember. So now we can find the vertex. The vertex is just -1, 2, and that's it. You know, so pretty easy. Now we just have to find another point. If we plot that, it's going to be about here, and I'm going to try 1, x equals 1. So let's let x equal 1, and then we're going to plug that in to find the corresponding y value. So y is equal to 1 plus 1 squared plus 2. Whoops, forgot to put the negative in front there. And then we just have to simplify that. And we get -4 plus 2, which is equal to -2. So -2 would be here, and we can use symmetry to find the other point, which is going to be -3, -2, and this would be -1, -1, 2. And so let's make a table to keep track of all the points that we're graphing. -1, 2, 1, -2, and -3, -2. Okay, so now let's connect the dots. There you go. So again, we're graphing using vertex form. This is called vertex form because you can see the vertex just by looking at it. Let's try one more of these before you try one on your own. So again, using that vertex form, we can see that A is going to be 5, H is going to be 4, we change the sign, but K is going to be -6, we do not change the sign. Now again, this number doesn't really do much for us. It just tells us if the parabola opens upwards or downwards. It's +5, so it opens upwards. And the first step is to find the vertex, and we can see the vertex is 4, -6. So that's pretty easy. Second step is to find another point. So I'm going to try x equals 3. So then we plug in 3 to the original equation to find the corresponding y value. And y is equal to 5 times -1 squared minus 6. And -1 squared is 1. And 5 times 1 is 5 equals -1. So now we can make a table to keep track of the points that we're graphing. We have 4, -6, and 3, -1. So let's go ahead and graph these. We have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And it opens upward, so I'm going to be sure to have my point out of the way of the graph. And then we have 3, -1. So 1, 2, 3, 1. And then we can use symmetry to find the other point. And that would be 5, -1. And now we just connect the dots. And there you go. So let's put that last point in the table. All right, so you can take a screenshot. Well, actually, I'll just leave these in the window. And I want you to try number 16. Now, notice that there's a negative in front here, so that means it's going to open downward. So try number 16, and when you come back, we'll do it together. All right, we're back. So a is equal to -4, h is equal to -5, and k is equal to 2. So again, we change this sign, but we keep this sign. And step 1 is to find the vertex, and we already know the vertex is -5, 2. And step 2 is to find another point around the vertex. So I'm going to try letting x equal -4. And then we're going to find the corresponding y value by plugging it into the original equation. So we have -4 times -4 plus 5 squared plus 2. And just using PEMDAS, we add those in the parentheses together first. 1 squared is 1. And we have -4 plus 2, which is equal to -2. And you don't have to show all those steps. I'm just doing that for your benefit, just in case you, I mean, you really shouldn't be having trouble with PEMDAS at this point in the curriculum. But in case you are, so we have -5, 2 is the vertex, and we have -4, -2 is the other point that we're using. Okay, and let's plot the vertex. So 1, 2, 3, 4, 5, 1, 2. And it's opening downward, so I can put my point here. So we have -5, 2. And the other point is going to be 1, 2, 3, 4, -2 here. And mirror that point. So we have -4, -2. And this point is going to be -6, -2. And we'll just connect the dots. And there you go. So if you got something like that, good job. I kind of missed the point there, but you get it. Oh, let's put that last point in there. So -6, -2. All right, so go ahead and try number 17. And when you come back, we'll do it together. All right, we're back. So let's label constants. A is equal to -2, h is equal to +2, and k is equal to -1. Again, change this sign, keep this sign. So now step 1 is to find the vertex, which we see is 2, -1. And step 2 is to find another point around that point. And I'm going to go and plot that. That's here. So I'm going to try x equals 1. So now we're going to find the y value when x equals 1. So following order of operations, we get -3. Now we can put the points in our table. And let's plot the points. 2, -1, we already got that, and 1, -3. And that would be 3, -3. And so plotting those points, we get the following. And let's put that last point in there, so that would be 3, -3. So if you got that graph, good job. Okay, let's try one more of these. I'm going to keep number 17 and 15 in the window there. So go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. So let's label constants. Change the sign for h, but keep the sign for k. And step 1 is to find the vertex, and we can see that's -4, -3. Step 2 is to find a value around the vertex, so I'm going to choose x is equal to, let's see, I'll try -5. So we have to find the y value when x is equal to -5. So that would be 3 times -5 plus 4 squared minus 3. And that would be -1 squared. And just following order of operations, -1 squared is 1. 3 times 1 is 3. It looks like we get 0. So that point is -5, 0. So we can go ahead and make a table to keep track of the points that we're graphing. -4, -3, and -5, 0. So 1, 2, 3, 4, 1, 2, 3, and -5, 0, 1, 2, 3, 4, 5, 0. So that would be there. We can use symmetry. This is opening upward, and -5, 0, -5, 0, and 1, 2, 3, -3, 0. And there you go. So now let's just put that point in there, -3, 0. And so if you got that graph, good job. Okay, that was the class today. If you want to take screenshots to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, and number 5, number 6, and number 7, and number 8, and number 9, and number 10. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1. And in case you have a hard time seeing these coordinates, I'm going to go ahead and zero in on that. And here's the next page down here. Again, I'm going to zoom in a little bit more than usual. And the last pages here. And that's it. So remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And if you don't do the homework, remember, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I look forward to seeing you in the next class.